today's lecture that is on AI and decision tree, because we are hearing this term again and again. So,
Dr. Rajini, madam.
Yes.
Just 1 minute.
Huh?
1 minute, 1 minute.
Okay. Should I stop share?
No, I'll allow you to do, no problem. Dear participants, again, good morning. Good morning to all.
Oh,
I'm really happy to welcome Dr. Rajini Jain for this very important lecture on artificial intelligence and decision tree. As she said that she has preponed or some alteration was done due to understanding the importance of this training program and inviting and bringing best faculty, best professors from different institutions. In that respect, she is helping in this training, being a course director. And really, on behalf of entire team, as well as institute, because she is our own faculty, I welcome in this session. And again, I would like to inform you that attendance is very critical component of this training program, because it is a central government sponsored training program, and they are very particular with the attendance. If somebody is missing, skipping the lectures, then at the end, please don't ask us the certificate. That will not be given if attendance are short. So please attend, because it is not one day effort. We past 3-4 months we were struggling to invite the best resource person and best faculty to conduct this training program. So please take it seriously. And you are lucky people who have been selected, because we had around 1,000 applications. Out of that, we have selected you people. So you should be thankful for the organizing committee and the institute. They have selected you. You please attend it seriously. Otherwise, at the end, you will ask us the certificate that will not be given. That first day itself, I made it very clear. Please, thank you. And once again, Dr. Rajini Jain, welcome. And now floor is yours, madam. Thank you.
Thank you. Thank you very much, Dr. Saab. Let me share my screen to begin the lecture. As I told you, like today, this lecture is on very, burning topic nowadays. So that is on AI. Let me put my screen in slideshow first. Okay. So most of you might have heard about artificial intelligence. But sometimes I found that people getting confused what exactly it is. One of my target for this lecture is that you do not get confused with various uses of the word AI, which you find nowadays, because it is being used by everyone. But people have their own definitions. So how about the technical things, how the technologists view AI? So that is what we will see here. Then we will also have one decision tree concept, which is very small component in AI. This is a method of making a tree which helps in taking the decisions. So that also I will cover. And with there are number of softwares available for building the decision tree. Even R also it is possible. But for beginners, it may be little complicated in the sense in the very first lecture. So I will try to demonstrate building of decision tree also with a very user-friendly software, which all of you will be able to do. So in this particular lecture, we have two components mainly. First component talks about AI and its application, and the other component talks about decision tree, which are sub component of AI and which is helpful for describing your data so that you can take decisions based on your data. So these are the two things which we are going to cover today. You see AI, this shows like how AI has captured the whole world. So even AI is being used by the AI man. So let us start with one video. Can you hear the audio? Can you hear the audio of this video?
No, madam.
Okay. हेलो हाँ हाँ मैंने चौहान को भेज दिया था उसको फोन को मैं ना अभी बाद में करती मेरा लेक्चर चल रहा है So here the message is that now like we are overwhelmed with data everywhere, and to handle such data we do not have that much human expertise available. So we require these emerging disruptive technologies like AI for this. And now our agriculture is also not very far away for using this AI. And as you have seen, even our Prime Minister mentions in this Republic Day his message that we are going to, even our budget session also, there lots of emphasis has been given to such technologies. So this AI is being used in agriculture also, and you have been now growing up with all these technologies. I don't think there is anyone who is not using these technologies which are working on the basis of AI only. Then this shows some of the technologies, basically top short technologies, this particular, and you will find that some of them are based on AI only. You see, like you are basically detecting where the irrigation is required, and it is reaching to you see drone is over the field, and it is giving farmer some advice on where to do what. So robotics is being used for plucking the fruits, and then even sorting them out into different categories. So this is sensors like are there inside the So basically what we have seen is that we require some kind of data driven technologies which can help our agriculture, which can advise the farmers, because number of experts are less to advise the farmer to take care of their needs. Here is another like helping farmers. AI is there, but so far like I can show you or see in you will see livestock also it is helping. So basically cameras are there, they monitor each of the cow or each of the animal. They recognize the cow's face and then they will continuously check each of the cow for signs of disease and all. So AI flags any changes to the cow like eating habit or weight, and then farmer is notified about what should be done for that particular animal. So this, like you have seen some application. So basically, let's see some overview and how AI has evolved. This term AI, it was first coined in 1956 by John McCarthy. And then like it became more popular, but people have not still heard about this. In 1997, IBM made a computer which was called Deep Blue computer, and it was able to beat the Russian chess master Garry Kasparov. So it was at that time like people started taking seriously about this AI. Then in 2011, a sub branch of AI, that is machine learning, came into picture. And in 2011, IBM made another computer, that is Watson. It also beats another human player on US game show Jeopardy. So that was done on the basis of machine learning. So then we have deep learning. Now in 2006, still many, only the experts in the area, they had knowledge of AI more till 2011. But from 2016 onwards, Google make one program called AlphaGo. So it was able to beat the master of this game, Go Master, Li Sedol from China. So this Google's AlphaGo, it beat this fellow. So then deep learning. So with the help of deep learning. So that means like three breakthroughs are, one is the term AI itself in 1956, then the term machine learning. So AI means it is a branch of computer science that aims to create intelligent machines that can mimic human decision making process. And this machine learning is, yesterday you saw one example which Dr. K.N. Singh showed, that he categorized his algorithm into machine learning because it is learning from the data on its own. So that is machine learning. And deep learning, all of you have heard about this neural networks now. But when these neural networks, in these neural networks, we have number of layers to solve the problem. So when this number of layers goes to thousands and millions, so it becomes multi-layered neural network, and it comes under the branch of deep learning. So in this particular training program also, we have lectures on deep learning also. On this Saturday itself, you will find some interesting application on deep learning. We have some lectures on machine learning also. And this decision tree concept, which I am going to show you, that is based on machine learning. Yesterday itself you had. So one should not get confused between them. AI is a big domain. All artificially intelligent applications, they comes under the umbrella of AI. And machine learning is a sub branch of AI, okay, where we are learning from the data. And deep learning is also one of the algorithm for the machine learning. Machine learning has many algorithms. Decision tree is one machine learning algorithm. Clustering is also one machine learning algorithm. And yesterday you did that lasso or regression. They also comes under machine learning. And deep learning is one of the algorithm of machine learning, which is the most popular algorithm. But people make use of these terms synonym to each other. Okay, but still it is preferable if you have knowledge of this. So this slide shows like how earlier chess in 1997, this Deep Blue computer, he beat the Gary Kasparov, and then in 2016, again the history is repeated. A challenge match was played from 8th to 15th March 2006, and it took so much time to defeat this Lee Sedol. So one is human and the other is the computer. So then these are also different components under artificial intelligence. Okay? Because when people use the word AI for their work, so they are not wrong, because there are many things under AI. So some I have already told you. You see the umbrella of AI, and then we have like this AI, it has machine learning, and machine learning further has deep learning into it, and all other algorithms have been put into this branch of predictive analytics. Then we have natural language processing. Now, Miss Gayatri, please mute yourself. Yeah. So we have this natural language processing. Dilip, have you started the recording? So we have this natural language processing. You know, Google translates the things, and so that comes under the concept of natural language processing. So basically, it is a translation, classification of the language, information extraction from your own language. So that comes under natural language processing. Then speech. Nowadays, you know, when you speak, then also a WhatsApp message can go. Google Assistant can do this. So speech to text and text to speech. Even when you watch YouTube, captions are there. So that again is a use of AI. And then we have expert systems. Also, so many expert system, rice expert system, wheat expert systems, expert system for helping farmers in diagnostics disease. So they also comes under this category. Then planning, scheduling, and optimization. So, for example, you want to know like how to optimize the sowing process. I mean, where to start so that it is faster, it doesn't disturb the field. So all these things. Similarly, irrigation, scheduling, when to irrigate, when not to irrigate, to have the maximum efficiency of water. So these concepts also under AI. Robotics, all of you are aware of. Then another very popular branch of AI is visioning. So, you know, it is under this component, this Tesla, like, and Google, they are targeting this driverless cars. How that is possible? They will make use of machines coupled with visioning. So camera will see, and then that data which camera will capture, that will be recognized using the image recognition algorithms, and then on the basis of the decisions, it will be conveyed to the CPU of the car, and it will take the decision on like which direction to move, whether to slow the speed or how to park and other things. So research is going on in all these fields. 1 minute. Just give me a minute. Yes. So, so this also talks about like how all of them, these techniques, they are bringing intelligence into the machine. Since it is machine-based intelligence, we call it artificial intelligence. So I will not go into this in more detail, because slowly you will understand. I have already told you, some people consider this are the same thing, but I have told you the difference, that AI is a broad general term which used to describe machines that do the tasks which are similar to human intelligence. Machine learning is a subset of AI which enables intelligence. So machine learning algorithms are the backbone of AI, because it is only these algorithms which gives power or intelligence to the AI. And so it is with these machine learning algorithms that machines get the ability to learn and adapt. Then deep learning is a subset of machine learning, okay, which is inspired by interconnected layered neurons of the brain. In brain, all of you know, we have so many neurons which are interconnected with each other. Similarly, in deep learning, we have lots of neurons which are connected with each other. So we will have more details of this deep learning in our subsequent lectures. So it says 2010 was an year of AI. And when people started adopting this AI technologies, this chatbots in customer service, nowadays you go to any site, an automatic chat box will come. So now more and more business will move towards these chatbots and virtual assistant. So so now basically our challenge in agriculture is to increase global food production 50% by 2050, so as to feed an additional 2 billion people. Now, how AI will help here? So it will help by automating our farm equipments. Machine learning helps equipment avoid obstacles and monitor plants to save the water. So by using these automatic equipments, you will be able to save more water. You will be able to detect the pest infestations, and sometimes early detection will allow farmers to act quickly and minimize the losses. And you can also identify the plant disease. And so far, algorithms can identify 26 disease in 14 different species with 99% accuracy. So this is one which is from the FAO. Then some applications, AI and pest, all of you know about it. Then this shows now, like earlier, AI could now automate close to 50% of jobs in the Western world within the next 2 decades. Main applications in machine learning are computer vision, robotics, natural language processing, and data mining. So future applications of AI will be, now farm mechanization will move towards precision agriculture. Diagnostic APIs. Nowadays, like you will see apps which helps you to diagnose this disease, that disease. But earlier, next thing will be, you will have apps which will give you the personalized treatment. Even now also, like we found so many apps which are giving personalized treatments on the basis of your parameters. Then in automobile industry, self-driving cars, then social media also, you know, intelligent filters are put. So facial identification, you put a picture, it will search similar pictures. It will find out whose picture is this and tag that person automatically. So then you have payment modes. You know, cryptocurrency is coming. Again, it is based on AI. And this, without AI, these financial services are not possible, because this fraud has to be detected, and that is possible only with the help of these AI-based machine learning algorithms. This shows precision weed detection. I will not, for example, it shows like some drone has detected that this is the weed here, and then weedicide is sprayed by the machine only on that particular portion, saving the other portions from the unnecessary chemicals. So this Niti Aayog, like it has come up with these applications for in India for AI. It says like we will have smart drones to survey the fields, map the yield and soil variations, enable applications of inputs, and map the productivity. Then we have autonomous tractors, like we are talking about automated cars, autonomous tractor, then weather forecast, soil sensors, then agri-bots. We have now chatbots in all domains, especially in commercial things. So agri-bots are required, and they will eliminate 90% of the human labor. Crowdsourcing, all of you know where information is captured from the crowd, and on that basis decisions are taken. And then vast of farming data, you know, soil health cards and other things. We are having data of almost every farm. So these are some of the things which Niti Aayog says for the benefit of the farmers. I'm skipping actually. Also I'm skipping. So then, like we have some kind of assignment for each group. You need to discuss among the groups, and each one on the basis of group one, like they will find out, they'll prepare some 1 or 2 slides regarding current scenario of IT development in Indian farming with reference to AI. Okay. And then for group 2, it is what are the challenges and development needs for smart farming in India. Like what are the prerequisites for bringing smart farming in India? And the third is, if at all we want to have digitization of Indian farming, then what are the challenges and how should we tackle those challenges? This group 3 task. Group 4, how and what would you advise? Suppose you have to give some advice to the government for the Vision 2025, then what should be your advice? Even though although government is taking some decisions in that aspect, and so what ICR should do, how ministry should change farming transformation into intelligent farming era. So then how should agriculture education be modified or to increase the use of AI? And or this group 6 has an option, a very burning topic which always comes to mind is whether AI is going to create unemployment in the Indian system, Indian scenario. Because the moment we say it is going to replace that many people's work, and this is the immediate question that comes to us. So all of you can note down your respective things and discuss among your groups, and then you come out at some 2 slides based recommendations or things based on your things. So in a nutshell, like if I want to sum up AI, I would say in AI is going to be very much important in agriculture. Now growth in agriculture will be driven by IoT. This IoT is another concept which comes under this AI domain. Sometimes people wonder what is AI, IoT. So IoTs are nothing but some kind of sensors which have the chips, and these chips are used to basically generate the data. Data will come into your computer automatically. They are connected with the computers through clouds. Okay, so for example, you have a chip to detect the moisture in the soil. So one IoT sensor which has been made for this soil moisture detection only, that will be put into the field of the farmer, and the data which will be captured by it, that data will come in the clouds, and the person who wants to send advisory to the farmers, or the farmer himself wants to know the level, that person will be able to see that data, and they may recommend farmers on that basis. Then image-based insight generations. These are some applications which I already discussed. Identification of optimal mix for agronomic products, health monitoring of crops, automating the irrigation, and then drone-based technologies. They are going to come for soil analysis, field analysis, planting, spraying, monitoring, irrigation, and automated tractors and drones. So these are some importance of AI in agriculture. Okay. So this was in brief. Because we have less time, so I had to skip some of the videos because I want to give some time for this decision tree. Now, as I told, this decision tree is an algorithm which comes under machine learning. So this is how a typical decision tree looks like. So what are these N1, C1, C2, and then these circles? So that we will see in this particular presentation. So this shows the basic concept of decision tree. It is an important data structure. So means it is nothing but a method to store or summarize your data. Like mean. Mean also summarizes your data, but it summarizes with one number. Same way, decision tree is also a data structure, and it helps you. It is a graphical data structure. You can say it helps you solve many computational problems. In your left, you see 3 variables are there. One variable A, which can take value 0 or 1, one variable B, which can also take value 0 and 1, and one variable C, which can also take value 0 and 1. And then we have a function f from M0 to M7. So this function is nothing but it is telling you the decision. Okay, if A, B, and C all three are 0, then it is M0. If 2 are 0 and 1 is 1, then it is called M1. So, I mean, the typical decision tree, binary decision tree, binary means your variables can take only 2 values. That is called binary tree. So now instead of alphabets, I have put some values there. So it says, let us try to understand this. If A is less than B, okay, in the topmost circle, we check whether A is less than B. If the answer is yes, true, then we check whether B is less than C. If so, we can reach to this decision that A is less than B, less than C. If not, we will reach to the other decision, A less than C, less than B, and so on. So these are the, so then what are the features or characters of decision tree? Decision tree may be Henry, means number of branches. Like just I told, for binary decision tree, there can be 2 branches. Yes or no? Here number of branches could be Henry, N. And there is a special node called the root node. Can anyone think of which is the root node here? The root node is this gender here. The topmost node is called the root nodes. All other nodes which are inside the tree, they are called the internal nodes. And all nodes drawn with rectangle boxes are called the terminal nodes. These are the terminal nodes. Edges of a node represent the outcome for a value of the node. These are the edges. For example, gender. What will be the outcome of this gender variable? It can be either male or female. So it will be F, this is, or M. So based on your value, you may proceed across the path. One more feature is, decision tree is not unique. So there, for the same data, for the same problem, there can be many decision trees. And that's why that concept of random forest and bagging trees, boosting trees, that comes into picture. Yesterday also Dr. Ken Singh mentions about random forest. So decision tree are helpful in doing the classification task. So they help us to classify the data. Edges are the value of the attributes. So these are called the edges. And external nodes are the outcome of classification. So like this, they are the final outcome of the classification. And we are representing here with square brackets. Then this is one very simple example of making use of decision trees. You see here, we have some animals from the animal kingdom. Human, python, salmon, whale, frog, komodo, bat, pigeon, cat, leopard, turtle, penguin, porcupine, and then we have salamander. So these are some of the animal names from the human kingdom. Our job is to find out, to make a tree which can tell us which class that particular animal belongs to. Okay, so this is what we want. All of you have done such kind of exercise during your school days or during your MSc. So here we have these variables. So if we want to make a machine learning model for classifying any animal you have and finding out which category the animal belongs to, this is the class variable. So assigning a class to an unknown variable is known as classification. So body temperature, skin color, whether the animal can give birth, has the legs, hibernate or not. So all these are extracted from the given data. And then this table has been made first. Now our job is, somebody comes, okay, what will be the label of dragon? What will be the label of shark? So if dragon and shark data also comes here, what should be assigned to them? That is the question. So now you see, question is posed in this form. You know everything about this particular monster, but you do not know this label, class label. So we can make a decision tree. Here you see, this decision tree says, how will you interpret this tree? That is a question. It tells you what is your body temperature. I mean, your means your animals, which you want to classify. Here in this case, the animal is Gila monster. Okay. So on the basis of that data, machine learning algorithm of decision tree, it will be able to make this tree. Now let us see, I will ask someone to tell me how it will decide what should be the branch for this Gila. So the branch is, how will you go? It says body temperature, cold. So that means you come here. It says if it is body temperature is cold, it is a non-mammal. That's it. So you have given the class to it, that it is a non-mammal. So we, if whenever we ask some questions on the basis of tree, then either it will give you the class label or it will ask another question till you get the class label. So all these questions and answers, they are organized in the form of decision tree. So we can say decision tree is a hierarchical structure which is consisting of nodes and nodes and edges. So it shows, suppose you want to know whether the fruit is rotten or not. So we made a simple decision tree. So this decision tree is on the basis of color. So it says if the color is red, it is not. If the color is white, it is yes. So this is the formal definition of the decision tree. Oh God. So we have a decision tree definition. formal definition. You can go through it. It is not very tough. It says you are given a database. In database, you will have these rows. Okay? Where Ti denotes a tuple. Tuple here means, you know, from set theory, it is a row. And each row will have number of attribute, means field or variables. And also each of these rows, they will have one of these classes assigned to them. Okay, for example, in the previous example, the classes were C1 and C2. C1 was mammal, C2 was non-mammal. So like that. Decision tree is a tree associated with D that has the following properties. These properties I have already discussed, that there is an internal node, there are edges, and there is a leaf node. So now comes how to build the decision tree. So for building the decision tree, two approaches are there. One is top-down recursive divide and conquer. So what does it mean? It means on the top you give some variable and you take its values and you make, if that variable can take suppose 3 values, then you will make 3 branches, and in each of the branch again you will ask some question and you will so on continue till you get a pure kind of data. Pure kind of data means where all the data items, they belong to one class. But it is cumbersome to use. Cumbersome to use by non-statisticians. So there are some better algorithms available. They are like this is called modified greedy strategy. So here ID3, C4.5, CART. So these are some of the algorithms. Now, before I go further, let us see the demo of decision tree. Then we will my screen has hanged basically. Let me just share. I have stopped it and I will share again the screen. For doing that, for seeing the demo, you will require one software which is called Veka. You make use of Veka 3.8.6, which is free. I have put this there. Let me share the screen and show you. In Google, like you type here Veka 3.8.6 for your respective machines. For example, I am having Windows. For Windows 10, you can give this and then you search. So you will get downloading and installing Veka. So many of this is there. Here also you get this Veka 3.8 download free. Even though Veka 3.9 is there, but this is the most stable version. Okay. So latest version, there are 2 versions of Veka. Veka 3.8 is the latest stable version and Veka 3.9 is the development version. So changes are still being done in 3.9. So you should download this, and on net you will find how to download and install Veka. It is very simple. You will get a self-extracting file like this. Let me show you. This file, you can note it down, this file. Those of you who are viewing from computer, they will know. This file get downloaded. 3.386 Azul Zulu Windows. Okay, so this is nearly 1 GB file. So you simply have to double click on this, and you can say by double clicking that install everything, and do next, and you get the Weka installed on your system. So let me show you how do we build a decision tree in a very simple manner. In between, let me see. Okay, I will answer this question at the end of the session. One question is there. What about the reliability of results of AI? That we will see later on. So then I would have to start Weka. So I have already installed for this class purpose Weka 3.8.6. I hope all of you are with me. I hope my things are not okay. Yeah. So I just open this, and once you open this, you will see a window, and this is a bird on which name this Weka software is kept. It was developed in New Zealand in University of Waikato. Okay, so this is very useful and most popular software which is used. So in this software, you have number of facilities available. But today, even documentation is available free of cost everywhere. So very good help is available, but I will just introduce you to this Weka using decision tree. So you click on Explorer here. Okay. So we click on Explorer. So this window will come. So in this window, let me explain you a bit of this window. All the things are grayed. Why they are grayed? Because we have not yet selected any data. Okay, my two windows are opening now. Okay. So, okay. Actually, when I double click, many windows opened because my mouse was not working. So I'm just closing the two extra ones which opened. So one of them I will use. Now it has everything which is required for developing machine learning based models. So first thing is open file. So it has provided some files for learning purpose. I will choose the data which is already available there. For that, I will search for that data. Data will be found in Weka itself. So I will do C program files. I will go to Weka folder, Weka installation. And then within this Weka, you find this data folder. So data folder gives these data files in Weka format. Okay. So these are there. Even you can open also some of them and see, like for example, I can show you what is the format of this. I have opened this notepad here, and let me show you one small this thing, weather.nominal. It is a very small database, small file, and I will open it in notepad. Okay, once I am in this mode, if I take it out and then it will open, but by default, if I open it, it will open here. You can save that file somewhere else and open using notepad also. So, but Normally you will not require, because VACA is self-sufficient for any task. Now you see some of the things which were earlier grayed, they have become active now. You can use all of them because one data set is open. So you can see this data using edit command also. You click on this and you find like this data has only 14 tuples or cases, right? Outlook, this number is an extra one. Why? Because you see here it is not displayed. So we have only these 5. So here, let me just tell you about what is this data set about, so that you will be able to appreciate the tree for this. This is regarding, all of you are fond of cricket matches. When the match get cancelled, then like you are disappointed. So here on the basis of some parameters, weather parameters, we are predicting whether the match will be played or not. So for this purpose, some intelligent human being, he collected the data of 14 days, where in some days match was played. Like on day number 1, there was no match. There was no match. Here, day doesn't mean that today, tomorrow, day after tomorrow. Day means the day on which the data was collected. So then he has data of one more day where the match was played, another day where the match was played. So now on the basis of, he knows, okay, outlook for that particular day was sunny, temperature was hot, humidity was high, and wind was windy, whether it was heavy winds or storm kind of thing, false. Or true means yes, it was there, false, 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 and so on. So this is the viewer, data viewer, where you can view your data, how it looks like. Then it also helps you to see the summary of each attribute. You see, here it says this outlook attribute has 3 values: sunny, overcast, and rainy. Okay. There are 5 cases, count 5 cases of sunny. Here also graphically it shows that. So this is the sunny variable, which is having 5 cases. And it has another variable, overcast, which has 4 cases. And another variable, rainy, which has 5 cases. Okay, and this red and blue, they tell you about whether the match was played or match was not played. Okay, so like we can see here, on sunny days, we have 50% cases where match was played and 50% cases not played. So in case of overcast days, all the days match was played. Then in case of rainy, we have some days, more days where match was played and not played, and few days where match was played. So then similarly, you can see the other variable for temperature. What are the values? For humidity. Then for windy. Then for play. Play is the class variable. where we have 9 cases and 5 cases respectively of different variables. You can check here in this play. Play में 3 and 3, 6 and 3, 9 cases of yes and 5 cases of no. 9 cases of yes and 5 cases of no. Match was not there. So one is, this helps you whether your data is properly loaded or not. Now, once you have seen this, it also tells you missing cases are 0%. There are no missing cases. I will take one case where there are missing cases, if time permits me, a slightly bigger file also, which is not there in the VECA. We can take from external also. Now you open this tab, classify. So for classify, you can choose various classifier algorithms. Choose, you click on choose. So number of classification algorithms are there. So, you have to select one from the trees. They are classified on the basis of base, on the basis of functions, lazy, meta, miscellaneous, rules, etc. So now under trees, choose classifier, you will choose under trees. So in trees, you have various type of trees. This, you see, random forest is also there. If you do not know how to make it, then this J48 is the most popular algorithm which is used for making the decision tree for all kinds of data. It works for the textual data as well as it works for the numeric data also. So once we choose this, it takes the default parameters. That confidence limit is 0.25 parameter is this, but it is not required. They are the default values. So now I will answer that question which was asked. How much is the reliability of AI based algorithms? You see, AI based algorithms are as much reliable as your other statistical algorithm. Only thing is, in mostly statistical algorithms, we make use of R square, RMSE, or mean error or absolute mean error, something like this. So here also, there are mechanisms which tells what will be the performance of this given model. Okay, so now it also depends on how well you design your algorithm to make the model. Yesterday also, we had a term from K.N. Singh, which was telling we use the model for training past data, based on past data. And we will put the other data to this model to test, to give us the answers. How that is done, let me demonstrate you. So as I told you that it depends on how well we design the case. So there are various methods. Let me first design using cross validation. Anyone who is aware of what exactly is cross validation? So it is a designing thing, like to design your experiment. I have chosen 10 folds. And once I choose this, maybe later on, like we will discuss more about what exactly it is. Then I say start. So see how simple it is. You have first only two-step process. First step, you have loaded the data into the software using this pre-processed tab. Second step, now you are simply using this classify tab. Here you choose the algorithm because Vecca is a working bench. So it gives you many algorithms. It is not exclusively for one algorithm. Like yesterday's software, it was for one algorithm. So since it gives you only facility to interact with, to develop model with one method, so it was simple to use. But here it is having many algorithms. So naturally you have to choose. So you have, by clicking here, you have chosen the desired algorithm. Then you will say cross validation, and then you will say start. Here you give start, and within seconds it will give you the model. So here is the model. Phone people may not be able to view it, and I cannot increase its size also. Before this, let me show you, we can visualize in graphic mode also. Visualize tree. You see this model is there. This you can save also, but before saving, I would like to visualize the tree. You see, the tree has been made. So this tree helps you to now take decision whether the match will be there or not. This is based on that data. So it says, first you ask, what is the outlook today? If you, for example, in Delhi today is sunny. If any match is scheduled today, then definitely we should ask how much is the humidity. I say humidity is not very high. So we come to this route, which says humidity is normal. So it says match will be there. Okay. Similarly, if in some location, even though it is sunny, but humidity is very high, so the match will not be there. Then we have outlook is overcast. So if it is cloudy day, then match will be there. If it is rainy day, then it will ask whether wind is there or no. If it is windy, means strong winds, then no match. But if it in very less, then it will be a match. So this is a simple tree which can be made using Vecca. Now, I mean, this is for visualization purpose. If small trees are there, you can keep it in your table and you can put it. Coordinator, you can allow Dr. Dalip Beshnoi from the attendees to allow to talk. He wants to talk something. He has raised his hand. Just ask him. Let me stop share so that I can see you people. Dr. Dalip, Dalip Beshnoi, can you talk now? Okay, he is saying no. So maybe that was accidentally, some hand has been raised by him. So I will come back. And I will share my screen again. Right. So this is the model. Even we can save this thing, but the same model is presented here in text format. So it is giving you everything, like which is required normally while we are publishing the paper. For example, it is telling which algorithm we are making use of. You see, Vecca में they are making use of classifier tab. Within that, they are making use of trees tab, and within that J48. And then some parameters has been passed. These are the default parameters. Name of the data is this. There are 14 cases in the data. 5 attributes: outlook, temperature, humidity, windy, and play. I'm telling you how to interpret this model, how to read this model, which is generated so easily. In R and other things, you have to write a big code for generating such model. Now you have this tree. So this tree is here in textual format. It is same thing. It says on the top, you will ask whether outlook is sunny. If it is yes, then you will ask whether humidity is high. If it is high, you will say no match. And we have, the model is saying, I have the support of 3 data points for this. If humidity is normal, it says yes, the match will be there, and it has support of 2 data points. This support is less because our data set was small and I used it for illustration purpose. Then it says, if outlook is overcast, match will definitely be there because it has support of 4 cases. If outlook is rainy and windy is true, then there will be match and it has support for 2 cases. For windy is true, no match. And then windy is equal to false. Then it has that match is there and support of 3 cases. It also tells you that there are 5 leaves and size of the tree is 8. So what are leaves? Let me again visualize the tree. So it says number of leaves are 5. So the terminal nodes are called the leaves. 1, 2, 3, 4, and 5. Okay. Then size of the tree is 8. So total, how many nodes are there? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is this. Now, another important parameter to know whether the data, whether the developed model will give us good performance. Here is the performance parameters. It says this model at the moment can classify with accuracy 50%. Okay. And like other parameters are also there. RMS error, relative absolute error, root relative squared error, total number of instances, and so on. And why this error is that much? Because our data set was small. If you want to learn from data, naturally you should have enough data. Because otherwise, how learning will take place? So far, like AI cannot dream, basically. It works on the data. Only thing is it makes learning from the data easier for you. So this is regarding this. Then another thing which is used to check the performance is this confusion matrix. Other things also you must have heard of, whoever is doing analysis, like TP rate, true positive rate, false positive rate of this model, precision, recall, E measure, F measure. So these are some statistical performance measures which are used to know whether the developed model is good or not. So for this example, I used only for demonstration purpose. This is not the model which can be used for this weather model for actually predicting the things. I will use another for this. And then there is a confusion matrix, another term related with AI-based modeling. So this confusion matrix, like here is the given classes, like for A, we have 5 cases and 5 are detected as yes from the model. For B, we have 4 cases and they are detected as 4 no cases, but detected as yes. So like that it is used. Let me quickly use another file. Now you have seen the whole process of making the tree. Now I can go quickly and take some bigger file, again pre-process, and same model will remain in the memory. Later on also we can save them. So I, by default, since I set it earlier, so the data folder will open. Let me take this iris data. Iris you have heard of earlier also. So iris data. So this is all real values. It tells you. So first variable selected is sepal length. Sepal length minimum value is this, maximum value is this, mean value is 5.8 and standard deviation is 0.828. And it is showing you here the class. Okay. So for sepal length, how the class sepal is dividing the classes. How many classes are there? That also you should know. Here there are 3 classes. Iris is a name of a plant and which has three kinds of flowers or 3 kinds of varieties. Iris setosa, Iris versicolor, Iris virginica. Okay, and these are the number of cases. So our job is to classify, like you will be, suppose you come across a plant, you know it is iris, but you do not know whether it is setosa, versicolor or virginica. So how you can make a tree which helps you to diagnose the variety of that plant. So for this, you again open, file is already open, so your tabs are grayed out here, and you can select even these because you want the model on all the 4, and now you have to classify it. So classification, let it be there, no need to delete. These models will remain at the end, whichever you want, you can save them. So then you have to choose the classifier. I choose under trees J48, and then this time for designing, I make use of percentage split. I say this is also an important part while using the machine learning model. Whatever data you have, you cannot use the whole data for training purpose. You have to make splitting of the data. One part you will not see while building the data. You will keep it at safe place later for testing that how your model is performing. So I have kept 66% of data only for training purpose and remaining 44% for testing purpose. So I say percentage split it on 66. Now we start. So once I start, you see, these are this data has 150 samples. So now it is telling you there is no chance of confusion because the summary it gives for the model, it mentions that it has this data which has 150 cases, these many variables, and how testing is done. 66% splitting is done with 66% cases. So which is training data, and the remaining 44% remainder is the test data. Then it gives the tree in text form. Here you can see how it is helping. So let me visualize it because it will not only be bigger, but the tree is same. You see here. Just right click on the model and say visualize. So it gives you, okay, this is the maximum width which I can get out of it. Even if I enlarge it. So it says, first most important is you see the petal width. If petal width is less than 0.6 size, it is this variety. If it is greater than 0.6, then again see whether petal is less than 1.7 or even greater than 1.7. If it is greater than 1.7, then you call it Iris virginica. If it is less than 1.7, then again you will check. If it is less than 4.9, then it is Iris versicolor. And if it is greater than 4.9, it is time for examining the petal width. And you get, depending upon width of the petal, you get maximum disc. Iris virginica and Iris versicolor. Okay. Dr. Sunil, please mute yourself. Dr. Sunil, mute yourself. And I request the coordinators to mute the participant immediately whenever there is a disturbance. So this is how this model works. Okay, now I think we should take questions because R also it is possible, but the code requires little bit more learning. So I did not choose R to demonstrate this decision tree to you. I did some application also of this decision tree on NSS. So I will straight away show that. Yeah. So it is a real example which was done on 54th round of NSSO data. In this training, we have a session also on decoding the NSSO data, how to get data from the NSSO in the next week or next to next week, depending upon the availability of the faculty. So we extracted, my screen is shared, right? So here, from all the states, to make it slightly simple, I took the data set of Haryana. My problem was I want to make a tree to find out who are the adopters and who are the non-adopters of this pesticide, insecticide, fungicide, basically chemicals. I want to know who are the farmers which are adopting the chemicals for killing the pesticide, insecticide, fungicide. So I put them into two groups, 1 and 2. So, and like why I choose Haryana, because I could show the benefit of this decision tree only on that. In Haryana, there were like 48% cases which are using and 52% which are not using. And it is agriculturally developed state also. While other state like Goa also similar, but it is very small state. So this sounded me a better state for taking this, but the model can be built even for other states because there are millions of records, millions of rows in NSSO data. So to see the functioning of the model and all, our computer, if we want to make that big use of data, then we should make use of some high-end computers because, so that your data can come into the memory of the computer and all. So for demonstration purpose, I took less cases here, which is 1832 cases from Haryana. And then these are the data. This is the data structure for that NSSO data. So many data points were there. This beauty of the DT is it automatically removes the unwanted variables. So then I could use this Veka itself for making this tree. Okay, so I did some kind of naming, like yes, there 1, 2 was written. Yes means 1 means yes and 2 means no. Like that, this has to be understood. Then this is the tree which we got. Okay, it tells like which are the farmers who are adopting the plant protection chemicals. So there is hardly any time to illustrate this. Then not only that, you can make use of this tree converted into simple rules like this. So if weedicide is yes, means farmer is using weedicide, then he is also using pesticide. This is one rule. And it says if farmer is not using weedicide, but crop is paddy, then he is using pesticide. So if farmer is not using weedicide, but crop is vegetable and fertilizer has been put on the entire farm, then he definitely uses pesticide. All of you are from agriculture, you can make sense out of these rules. Okay, so computer has learned these rules from the data, and now we can make use of our own intelligence, and sometimes algorithms are also there for that, to find out which rules are good for farmers. I mean, which of these should be highlighted as a, so this is rule-based model which has come up from the decision tree itself. And this is graphic-based hierarchical model which has come from the tree. So similarly, for non-adopters also, certain rules were made. And somebody asked about the performance measure. So we have like to improve the reliability of these algorithms. One thing is you should have proper training and test data, right? As I showed you 2 cases of training and test. One is the first case, cross validation. You can see Google and find out what is cross validation. And another is percentage split. So whatever data I have, I make partition out of that. Some part I keep as a test and the other part I use as a training. So when we are reporting the performance of our model, that is reported on the test data, not on the original model which we have built from the training data. So accuracy is reported on the test data. And then if you have so many models available, then which one to choose? So it is up to you, like what application you want to employ on that algo. It can be accuracy, it can be complexity. For example, COVID detection. Suppose we have some kind of hierarchical tree like this, then which of them is more important? Accuracy. When human health is into picture, then accuracy is more important. So like that, depending upon the need, one or many of the performance measures can be selected. So this is regarding how do we see the performance of the AI-based algorithms. Now I will stop my screen and I will take up a few questions if it is there. Let me first go through the chat. So one question is repeat the assignment again. So we will post the assignment on your group also, no issue. Then another is, it is a free software. Yes, it is free software and very effective and very user friendly. And then we have, can we use quantitative data also or only qualitative data? I have shown you both the examples. Iris data was quantitative data And this weather data was qualitative data. But in both the cases, since it is a problem of classification, so you're predicting with your class variable is qualitative data here. But there are trees which are called classification and regression tree, which can even work on the quantitative variable as the predictor variable. Some agriculture study example, I have already given you one example out of this. And I would appreciate if each group, besides doing that AI kind of assignment, also takes up their own data, which they feel is based on agriculture and where you can, some kind of classification problem is there. Good question. Can we import Excel data file in this software? Yes, it is there. When you are opening the file, it asks you the option, which type of file. By default, it will take ARFF, but if you select the type, it can take that also. And also on net, you will find tools which convert Excel file into ARFF file. Then that's all. And in Q&A, I think reliability of results I have already discussed. If there is any other question, just let me know. So I don't think there is any question right now. I know it might be relatively new topic. You might not have heard about it earlier, but it is a very effective modeling, very simple for the end user. Suppose, for example, you want to make a model for use by the farmer. Then farmer will not understand your R square. He will not understand your equation, which is the resulting model from the regression. He cannot apply that. I mean, some of them can definitely apply, but this kind of tree, it is very simple for anyone. And even SPSS also provides you facility for generating trees, but you have to buy that extra module. R also has it, making of the tree. Some of you who knows Python also provides this, because this modeling, tree modeling, it comes under basically machine learning algorithms. That's why this might be new for some of you. And in due course of this, like in this training on analytical techniques, you will find number of, we are helpless to cover all of them, but some good ones we are covering. We will be covering SVM, support vector machine, which is another machine learning based algorithm for classification. We will be covering deep learning. So you will get a, and its demonstration also, how it has been used in agriculture. Some of our research scholar from ISRI, he used that on real data. Now he's assistant professor in one of the universities, so he will demonstrate that. And then we have clustering. Clustering, you have heard it is used in this economics also, but based on machine learning, how the machine learning algorithm of clustering is little bit different. It is unsupervised classification. We also have that session. So even VECA also gives you. So rest is up to you to explore. So I think now 2 more questions have come. Okay, one question is, if we want to determine growth and other function like CD, then how to do that? This is not possible because you already have the function available to you. So you have to only fit that function. This AI is used where other techniques cannot be used. So this will be a straightforward fitting of your function. You already have the steps to compute that. Okay. Then while writing research paper, what are the components we must include? Okay, very good question. Basically, one thing is you should tell about the performance measure of the model. You can talk about the tree. If the tree is small enough, sometimes tree will be very large. So in that case, some sophisticated technique like pruning of the tree is done to make it simple. So that you can tell, and a bit of theory also you can add in this. It again depends on which journal you are using for publishing your paper. If it is some computer science based journal, then you may not include too much of decision tree methodology, because computer science journal papers, they will mainly cover modification or some kind of new computational methodology. If it is some kind of issue-based journal, plant-based journal, or our economics journal, then you can mention some of the methodology also, your model also. So, and of course, you have to look at the other papers who are using this decision tree. So that also you can do. So thank you very much, all of you, for listening patiently. Thanks again, and we shall meet at 2:30 again with a very good lecture on Farmer Producer Organization, FPO, by Dr. Vinayak Nikam. He has been working on this. We can give more examples of this. I mean, you can understand it from this point that wherever classification can be used, we can make use of decision tree. One example I have given you, adopter, non-adopter, or another will be like in cases of farmer, when farmers are taking loan, and the loans are sanctioned by the cooperative banks or maybe self-help groups or whoever it is, then they can, on the basis of farmers' characteristics, farmers' data, one can build a model straight away, small model, which can help whether this particular farmer is going to be defaulter or not. So this is another case. Then like, I mean, the list is endless. You yourself tell me the problem, then I can tell you, okay, whether it can be used or not. Simple one point formula for deciding whether tree can be used or not is classification. If there is some kind of classification, you can definitely use it. So I think I will be exceeding my time limit if I go further. So let us stop here, and thanks again. Thank you, each one of you, for listening to it. So I am expecting now the groups to be little operational and start looking at it. Each one of you think of some application and discuss among your groups. Okay. Thank you. So can we close this session now? Okay. So now we are leaving this session, and we will be back again at 2 o'clock. We'll make it open, and 2:30 the session will start. Okay. So I'm leaving the webinar now.